Hey guys, so in this video, this is the problem statement. So this is an oak tree, and as you can see, the branch is rendered correctly and textured correctly. Leaves seem to be textured correctly, but there's something going wrong with it because they appear shredded, right? So this is not what we want. We want proper leaves. So let's first look at the GLTF file, which this is a oak tree, and I have a video where I talk about how to read GLTF files. So I'm just quickly going to go through this. So we have one scene, and we have the scene has two nodes, and the what is the first node? It has some tree mesh, and it has it has a model view matrix to convert model matrix, sorry, which is translation, rotation, and scale. And then we have another mesh one, and again the translation, rotation, the model matrix. And each mesh, if we go here, we can see has three vertex attributes, and then if we go to the materials, we know that we will know that this mesh is for the trees because we have the blend mode, and this is the bark, which is opaque. Even the name say that, bark and leaf. So and this is the output we have, which is incorrect because something is going wrong in the ray tracing pipeline. So the way I'll start this video is when I was hoping someone could help me debug, and in future when I have more challenging bugs, I think I would need help. Me if someone volunteers to. But anyway, so what I'll do is I'll take a fresh repository, and if someone has to help me, if they need to set up the repository, so I'll just start fresh. And the way you set up is this is my repository. I'll include it in the link, and just copy this and paste the instructions. So we are cloning into the repository. Then we have submodules imgui tinygLTF, and then let's just get the do submodules update to get the to that third-party libraries which I'm using imgui. I'm not doing justice to it yet, but anyway, I have a lot of plans for that. But okay, dx11 12 examples. So that this is the clone repository. Just open the solutions file with Visual Studio 2026. It works out of the box. If you're using 2022, I think we need to retarget the solution. So this is my freshly cloned repository. This is my ray tracing sample. Set a startup project, and here in the header file I have the oak tree. Should it be oak tree? Yeah, oak tree. So let's just compile and run. So it is compiling IMGUI, and then the sample base, some of the camera, and then the GLTF loader, which converts GLTF to TX data structures, some helpers, and some utils, the data util, and the image loaders for loading textures. Then I have the shaders are being compiled, copying the GLTF files to the exe locations, and then here it is. We have our oak tree in ray tracing. So as we see, the trees are all shaded. Now, how do we debug this? How do we know where things are going wrong? So first, let's take a pix capture to see everything is okay. I didn't use pix to debug because I didn't directly use pix to debug this issue because we don't know where to look at. This has like pretty, I mean, two primitives makes it a little complicated, but anyway, let's see. So open the capture, start the analysis, go to dispatch rays, and if we see the output, yeah, we see the shaded tree, and this is the TLAS puff. This is the acceleration structure, which is sort of correct. Oops, yeah, which is correct. We see the bark, we see the leaves, so geometry is all correct. And if you go to the shader binding tables, hmm, I should be having two here because this is for the hit group for the opaque. I should be having a hit group for the mask. So the miss table, I have only one miss table, and the region, I have one region. And this is something weird. I didn't see this before. I have the local root signatures, table offset 0. Oh, what's going on here? Let us see the RayTracing.cpp. So the shader binding tables are set up in build shader tables. So I calculate the number of primitives in scene, and then I calculate how much is the hit group size, align size into total emprims, and then okay, when I'm doing this, I didn't calculate into total line two. Okay, for now let me just do this, but there's some repetitive code which I want to avoid. But okay, let's close this. So the hit group size was wrong, and that's why it was not showing two hit groups. But I don't think that's the issue here. Yeah, we still see the shaded leaves, but let's see if at least something has changed in pics, and we should see. Everything should be as expected. Any small thing, we should not have anything which you don't expect. So I'm expecting two hit groups, and I should see two hit groups. So start the analysis. That should have fixed it. Dispatch race and then go to shader tables, and yeah. So we have two hit groups. So why do we have two hit groups? Whenever the ray hits the park, it should run the opaque hit group, which has only the closest hit shader, and this has the any hit shader and the closest hit shader. But now let's not look closely into pics. The way I debugged this, I wanted to see what's going wrong, to gather more data here. So okay, what do we do now? So let's go to the shader and let's see the any hit shader. All my shaders are here. Ray tracing. Mm. So this is my region shader, this is my closest hit shader, where we access, and for the any hit shader also I do the same computation. I repeated the code which I'll refactor later. So we are essentially doing the biocentrics. I have a video where I explain all these calculations, so I'll link it here. So we are sampling the texture, and then we are checking the alpha, ignore hit or accept hit. So let's start by not by accepting all the hits so that we can see the entire texture without any transparency. So I change the ignore hit to accept hit, and so we see that there seems to be something wrong going on with the text, with the UV calculations themselves. So let's see what should be the correct output. So if I go to my hello world, which is a VSPS pipeline, and see the output here. Okay, first just let's run it to see if we see the correct output. Yeah, so this displays the leaves properly. Now what I want is I don't want any transparency. I want to see how the texturing actually looks like without that. So in VSPS we change the any hit shader, but in Hello World we need to change the pipeline state. So just let me go through this, and here I'm checking if the particular primitive has blend enabled. So let's make it false. So similarly in ray tracing, I'm checking the same thing, and then I'm choosing the hit group with any hit shader. Here I'm just setting it in the pipeline. So let us just see here how the texture should look without blending or transparency. It should look like this. I think it's certainly wrong there, right? Let's just take a screenshot of this to compare with what we have there. What do you have in ray tracing? And before that, whenever we suspect texturing, we need to look at the UVs tool. So let me just go to my VSPS, and as we saw, we have three attributes here. So where are the position, normal, text chord. So I'll be using my simple three shader, which is, it handles three attributes. And let's say input text chord. Oh, okay. So we should be using the frac one now. And anyway, I'll show that. And that's an interesting one because I'll just show two outputs 0, comma 1, and then so if you don't do frac, we see something. This is wrong because my the way the tree is textured here is it has texture values of -8.5, 7.5, something like that. So and the sampler mode is repeat. So to visualize the correct text chords, we need to just take the fractional part of the UV because generally UVs are like 0 to 1 and just put the wrapped ones here. That's more into a sampler detail. But anyway, so I think it looks almost the same, but there were some differences. But anyway, this is the right way to visualize the texture. So let's take a screenshot of this. I just want to highlight what would have happened if we didn't use wrap because I don't want to leave that hanging in the air. Yeah, so if you see, I think the bark uses wrapped textures, not the leaves. So if you see, the bark is all red now, and now if I use the bark once, you can see that the bark is smoothly shaded now. It has so it's like R and G channels are visible. So the leaves don't use wrapped, but the barks use wrapped textures. So yeah, that's important. We just write the frac here. Anyway, so since I have the screenshots, let us go into ray tracing and see. Let's see if the UVs are correct or not. So how do we do that? By going into our any shader, and then here we do this, but after we accept hit and insert, the closest hit shader is called. So in the closest hit shader, let us just say uh, payload color is float 4 of UV interpolated, comma 0, comma, and let's just look at the fractional part of it. This should show us the UV of, does it look correct? Let's hang on. This is, oh, I'm still running hello world. That was like, I was like, what is happening? Yeah, so this is ray tracing, and oh, the simple mistakes cost a lot. So yeah, the texturing is the UVs are all wrong. So no, what did I do is I ended my day yesterday and I took a break, and then I realized I was going all this on why UV is going wrong, and then it just struck me that what I was doing here is where do I bind the UVs? So when I bind the index buffer and the vertex buffer here, I am taking the UVs from the first from the first primitive. So I didn't change this part of the code to handle two primitives. So the trees end up reading the global root signatures UV. So if we go to the hit groups and see here, so my local root signature uses space 3. So my textures are in space 3, but my UV coordinates are in space 1, which means I'm binding only one SRV buffer. And my leaves are reading the bark UVs, the primitive first UVs. Now the proper solution for this requires some work because I need to change the way my descriptor heap the descriptor heap is organized. But in this video, I just wanted to show this and confirm that what do we do for the UVs? Let's say that instead of node 0, I'll use node 1 comma 0, and this is a UV buffer view. I need to refactor this because I don't want to repeat this twice. But anyway, we are getting the buffer UV vertex buffer resource. We are getting the UV buffers, and here I'm getting the index view buffer. I'll use the first ones. Okay, and then I will use even this. I'll use the first primitives. That is, I'm using in the global root signature. I'm binding the leaves UVs. So what is the expectation? The leaves must be correct. The bark would go wrong, right? So now in this, the leaves seems to be correct, but the bark is going wrong, right? So let's see if at least the leaves work now, and if this is indeed the solution. So let's go back to the shader and reset everything. So what do? I want to see the actual texture output. So in the closest fit shader, give the proper output, and the any hit shader, if it is less than this, let's just ignore it. Just ignore the hit. And then when I run this, well, we see that the leaves are correct and the bark is all wrong because the bark is now using the UVs of the leaves. So we go closer as we expect. The bark is like totally gone. So you can see the branches, everything are totally gone, and we don't have the bark texturing anymore. And now if we revert, if we say 0 0 0 0 0 0, we see that the leaves are gone and the bark is all right. Okay, I need to increase my camera speed. This reminds me of some of a Mr. Bean movie where he's waiting for a very slow vehicle. Yeah, so the bark is correct and the leaves are gone. Right, so how do I increase my camera speed? Yeah, go to camera and then this is move forward is 0.5, which is bad. Which is I just say at least 2.5, and the back let's keep it 1.5 so that if I overshoot I can come back. So this will at least let's see. I don't know, I need to smoothen the camera out and a lot of work. So yeah, this is faster. So the leaves are shredded and the bark is correct, and if I change it back, ray tracing, if I change it back, One, take the first primitives UVs. Yeah, the leaves are right and the bark is gone. Right, so the whole bark is gone because the texture is correct, but the UVs are wrong. Now the thing is, yeah, the texture uses the local root signature, but the UVs use global root signature. There are a couple of solutions, but I think the easiest one would be to move the UVs to the local root signature so that when the hit groups are indexed, I end up reading the correct UV. But that is not. It requires a bit of changes, and it might break my hello world, and I need to see everything because the way the descriptor heap is organized and the way the shader reads the table, the shader reads the accesses the UVs. It requires a bit of changes. I'm trying to make a generic GLTF loader and work it across pipelines, so it might not be a quick fix. Anyway, thanks for watching. So this is the issue. The final solution. I will make some changes today and hopefully that will fix everything.